Hi, welcome to my channel. This channel is against the Big Bang. I discovered the Big Bang is false. So we can go to the stars. The stars are close, not far. Okay, so in each video I cut from other videos and I comment them. So I take on one person. This guy worked on a Kobe satellite on micro background radiation. Micro background radiation, it is gravity, dudes. Okay, light, it is gravity. So Brian Greene interview World Festival festival like a science festival channel, and he was also the guy who worked on a Webb J Space Telescope. Matter, like matter, dark matter. So this guy, this video
is totally amazing. On my tie, I've got the nebula where stars are being born today.
Very nice.
And we can see through the dust. We can see the stars shining through the dust cloud. We see the wind blowing through space to distort the clouds of dust. We see the winds triggering the formation of new generations of stars. And we can begin to tell stories about how it works and do the math.
Yeah.
So eventually we might be able to tell you, how was a star like the sun with a little bunch of planets boring around it?
Right.
How does that happen?
Yeah.
Okay, if you watch that, you know this is the way I make the videos. But let me tell you like this: temperature is a limited function. Okay, so with your prediction, you know what it is. Your prediction. It's like I'm telling you, if you fly under a cloud of a rain cloud, you register some radiation, some everywhere is some loose free energy, and you will register it. Okay, so our galaxy is like this sphere, like a cloud, big cloud of water. You register some radiation in it. It does not come from the Big Bang, but it is the gravity itself. Okay, but if you want to understand, if you know even something, some mathematics, like a graphic, you see, I will make a graphic like this. Temperature, it is a limited function. Okay, you see these two. You make a graphic, like a stupid child can do this, but you understand this. The temperature, it is a limited function, so you cannot have that draconical energies that Weinberg books, like a 10 to the power of the 15 or the power of 14. Okay, you see, let's say 750 watts, okay, like 220 volts, you see, and this is a microwave oven, and you put a glass of water, like about 5 minutes, like time, you see, T1 T2, like T1 T2 time, okay, and the temperature in Celsius from 10 degrees, let's say cold water, it boils at 100 degrees. The temperature is a limited function. No matter how much energy or temperature you put in it, the function stops. Okay, that function mathematically stops. So you have these two times 5 minutes. Okay, 5, and you do like this. Okay, and the function stop if you know, like this. Okay, so you cannot go in billions of trillions of quadrillions of degrees, like Weinberg wrote in a 3 minutes of the. You do not know this, dude, the temperature, how you make physics. If you do not know this, you have like a pressure, like you said in this video, one on X, like you have pressure and volume, like see, like pressure and volume. And it is limited. If you pull this big, you make some infinities, and you cannot work with this. Okay, the temperature is limited function. Let you see another part, and I will speak. So this the idea. Okay, the temperature is a limited function. Okay, so microwave background radiation, I'm telling you what it is a part from gravity, a field. Okay, so watch another part. And
What would you say are the one or two big insights or discoveries or surprises that so far have come up from the machine?
Well, the one big surprise our feeling is that the early galaxies grew much quicker than we thought they would. They're bigger, brighter, hotter, more massive than people expected. And we don't know yet what's different between our plan for the universe and the actual universe.
Right. And so when were the earliest of these galaxies then forming?
The first ones we know about are about 200 or 300 million years after the Big Bang. So that's pretty far back. It's what we call a redshift of 12, 13, 14 even.
And what would you have thought based upon things that we knew before the Webb was up there?
We thought we'd see that far, but we didn't think we would see what we're seeing.
Yeah.
We thought the galaxies would be smaller, cooler, darker, and now we are surprised. We just don't know why they're that way.
Are there any great ideas bubbling up?
Well,
that
there are
you
a few.
think-
So the big question is, what are the first stars like? The stars today most of them are like the sun, a little bit smaller, a little bit bigger. It's possible that the very first ones were hundreds or thousands of times as massive as the sun, that they would burn out very quickly.
Sure.
And very quickly release vast amounts of the heavier chemical elements besides hydrogen and helium. So that's a possibility we're working on.
Okay, if you saw that John matter, matter, okay, black matter and dark matter, like energy equal and kinetic energy. You see, movement energy, not electricity, like Leibniz did. Okay, 1.5 mass time velocity square. So let's see what it is. Dark matter, dark energy. This is dark energy, is the kinetic energy of movement. Can you have dark movement? One is dark, two, or mass is dark mass or dark velocity. So to have dark energy and dark matter, because your name is like matter, what is dark? To have this, what do you pull to make this dark? Or the force times acceleration, like this, mass times acceleration. What it is dark matter? Your name is like matter, okay? If you understand what it is dark matter. So from force is dark, mass is dark. What is dark? So let me tell you now. Our galaxy is a big cloud, but a spherical one like this, and it contains many stones and rock contained, and it was like voided inside, like you make a thundercloud circuit in a thundercloud, and it was voided, like the planet were coagulating prior, and the stars were coagulating prior this. You see, I have pictures from Webb and Hubble Space Telescope. You see, Mendeleev chart. This is a star in our galaxy, like it is a sphere. You see, if this, you cannot watch it. It is a function. You see close, and it is a function like a conical function. You cannot see light from 1 billion years. Okay, this is a star, and if you know mathematics, you see how you are doing. You order some people to do some stuff there, like machines, but you calculate. You see, the gravity is not attraction. This will collapse, and the stars are not like our sun and do not form anymore. You see, you make this like from the center to here, 1,000 years. Can you show me how you make gravity? Like if you g over mass like this, like from Newton force or Leibniz kinetic energy, how can you make to propagate 100,000 years, 100,000 years gravity? And to grab this star 10,000 years, and this star's 5,000 years from the center. You make the equation. So you do not know mathematics. You simply make some designs and you order some guys, and this way you believe they're from a stream of incompetence from Europe. I'm from Europe, okay? These are simply stars, clouds, full of pieces like this. You see how big you can have light, like this, and they produce the radiation like this. You see how, and you can modulate it, and it does not go anywhere. Hubble made on recession of Andromeda, and you now say that Andromeda approaches, okay? And as clouds, okay, you can see unordered clouds like this, but they are statics, and some geometrical patterns, but they are static. Okay, and you see, and they are close, they are orientated towards us, because they are in this sphere. Okay, and they are small, and they do not have the sun earth dimensions. This does not have 1 arc second. Okay, so you see, they are orientated towards us, perfectly towards us. Okay, we can go to these planets, we can colonize them. The stars are putting clouds, the clouds are producing some electrical energy. This is the cause of gravity, of microwave background radiation. You will imagine a sphere like a cloud with big electricity. Okay, you imagine that you find some microwave, okay, like this, on watts and volts, you produce microwave, some materials. Okay, so the stars are small, you see, collapse. Okay, you see, like this, and our galaxy is a sphere. I showed to you some like see, and they do not go anywhere. They do not orbit. Gravity is a simple field of light, many tones and frequencies, and many, you see, and so clouds surrounding our galaxy. We cannot see the universe. Okay, this is the video for today. John Matter, on John Matter. Okay, we can go to the stars. The science is wrong. These guys only do some designs, and he took a Nobel Prize, but you do not know how they give the Nobel Prize, because Nobel invented the dynamite, a stream of craziness. Okay, was guilty, feeling guilty, knew that do not made this for mining purposes and to bomb people, and then he did the Nobel Prizes to another stream of incompetent and okay, you do know this, so maybe you are not incompetent, but when you know this, temperature is a limited function. You make cover. So okay, we can go to the star. The stars are more. The galaxy are simply cumulus of stars, small stars. Okay, goodbye. God bless. Like, share, and subscribe.